All right, so we're going to go over inverse functions. And so inverse functions is like saying or trying to look for the opposite of a function. So in this case, on our first example, we do have this parabola. They have a table that we need to use as a guide. So it has -2, -1, 0, 1, and 2, and we have our quadratic function here. So what we're going to do is write the points down. So at -2, our function is 1, 2, 3, 4. So +4. And then at -1, our function is -2. And then at 0, our function is 4. Oh, -4, actually. Sorry, I can't write that small. At 1, our function goes back up to -2. And then at 2, our function goes up to +4. So then your table B, which would be our, and I don't like calling it table B. This is going to be our inverse function. So I'm going to erase this here because I don't like that. I want to call this my inverse function. So your inverse function, or the symbol for inverse function, is f, and then it's like an exponent of -1. So it's read f inverse of x. And what we're going to do is we're going to swap the x in the y values. Okay. And so my y values become my x values, and my x values become my y values. 2. All right, so I'm going to go ahead and graph this here. And so we have 4, -2. So 1, 2, 3, 4, 1, 2. -2. So 1, 2, -1 is right here. -4, 1, 2, 3, 4, 0. And then -2, +1. And then 4, 1, 2, 3, 4, +2. And so I am going to connect these dots. And this is what this looks like. So it looks like our parabola kind of spun around a little bit. And so it says, does graph A represent a function? So the original graph, okay, graph A, which is what we got from table A. This is my graph A. So this one, if I try the vertical line test, that's how we check. We notice that our x values does not repeat. So yes, this does represent a function. Now, graph B, which is our inverse function, doesn't represent a function. So in this case, if we were to do the vertical line test, it would fail, because if I make this vertical line here, you will see that it crosses at 2 points at the same time. So this is not a function. Okay. But since we're looking for the inverse of this quadratic function, and we're looking for the inverse function, there's a way that you can do it to make it a function, is by restricting the domain. So if we were to take off this little section over here, this bottom section, and only worry about these numbers right here, then it would be a function, because if we try to do the vertical line test, it passes. So we'll get more into that in a little bit, but let's go ahead and try the next one. Undo. So it says make a table of values for graph A. Complete the table B by reversing the order pairs on table A. Okay, so table A and table B, which, like I said, I don't like the way it says table B. We're just going to say this is the inverse function. So we'll say f inverse of x. All right. So table A, -2 goes with 1, 2, 3, 4, +4. -1 goes with, oh, did I get that wrong? I did, huh? -2 goes with 1, 2, 3, 4, 5, 6, 7, 8. Sorry. This one should be 8, and the bottom one should be 4. And then 0 goes with 2. 1 goes with 1. And then 2 goes with, it looks like a half. It looks like a 0.5. And we will assume that. So let's go ahead and write our x values again. 0.5, 1, 2, 4, and 8. So 0.5 is 2, 1 is 1, 0 goes with 2, 4 is -1, and then 8 is -2. And we're going to graph this. So we have 0.5, 1, 2, 1, 1, which is the exact same point there, 2, 0, 4, -1, so 2, 3, 4, -1, and then 8, so 4, 5, 6, 7, 8, -2. And then we connect. And so one thing that I forgot to point out was that if you notice, they draw this dashed line here. And the reason that it's here is because your inverse functions will always be symmetric about this line. So it'll be exactly the same thing on both sides. So this line cuts both of the graphs into 2 equal parts. So it says, does graph A represent a function if we do the vertical line test? Yes, graph A represents a function. And then it says, does graph B represent a function? Yes, if we do the vertical line test, it passes. Yes. All right. So the tables and graphs on example 1 and 2 show inverse relations. All inverse relations have the following characteristics, and this is what I just mentioned. The independent and dependent values are interchanged. So we switch the x and the y values. That's all that means. And that the graphs of the reflections of each other are on the line y equal to x. So this equation of this line, the one that I highlighted here in pink, is your y equal to x line. And so your graph should always be symmetric. So here it says, if the inverse relation of a function is also a function, like on example number 2, then the relation is called the inverse function. The inverse function f of x is represented by f inverse of x. So that's what I explained to you guys in the beginning. So here are the steps, not just by looking by the graph, but to actually find the equation just using the equation itself, not using a graph. These are the steps. So you start off with replacing f of x with the y. Then your next step is going to be to switch x and y. Okay, from there, your third step is going to be to solve for y. And then your last step is to go back and make sure to replace your f inverse of x. Okay, so let's go ahead and do the first example. So number 3. I'm going to zoom in, but my first step is to replace f of x with y. So I'm going to go ahead and do that. Sorry. So it's going to be y equals 2x cubed plus 3. And that's my first step. All right, then I look at my next step. So it says here my second step is to switch x and y. So let's go ahead and do that. I'm going to go back down. And I am going to switch my x and my y value. So you write it as x equals 2y to the third power plus 3. Okay, then my next step is to solve for y. So this is my step 2. And then I'm going to start solving for y. So we're going to get the y by itself. So we have this 2 that's here with the y, we have the cube that's here with the y, and then we have the 3 that's here with the y. The first one that we need to get rid of is this plus 3. So we need to subtract it, and we're going to move it over on both sides. So we get x minus 3 equals 2y to the third power. All right, and then from there, our next step is to get rid of the 2 in front of the y cubed. So we divide by 2. Now, we can't only divide the x, we have to divide both the x and the minus 3 because they're both on the left side of the equation. Okay, we're not just done. We're not done just yet. Let me go back up and do my work up here. So then these canceled, and we are left with x minus 3 over 2 equals y cubed. Okay. Then our last step is to get rid of this cube root. So in order to do that, we have to take the cube root. Okay, so this cancels out. And then we are left with y. And then here we have the cube root of x minus 3 over 2. Okay, now we solved for y. We got the y by itself. So we're done with step 3. And then our last step is to replace this y with f inverse of x. So our final answer, f inverse of x equals, and then it's going to be the cube root of, we'll have to put a little 3 in here to show that it's a cube root of x minus 3 over 2. And that would be our final answer. All right, so if you didn't get it on that one, okay, we're going to do it again, and we're going to do the exact same steps. You start off by switching the f of x for y. And then next you switch your x and your y values. You solve for y. And then you set f inverse of x instead of y. So we're running through the exact same steps. Okay, so I'm going to switch f of x with y. So y equals 1 over x minus 2. So that was our first step. Okay, our next step is to switch the x with the y. Okay, so here it's going to turn into x equals 1 over y minus 2. And so our first step to switch is going to be, instead of doing minus 2, we're going to add the 2. This cancels and we get x plus 2 equals 1 over y. Now our next step is to get rid of this y that's in the denominator. So what I'm going to do is, let me go ahead and go a little bit up here. I'm going to flip the 1 over the y. So if I flip the 1 over y, then I also have to flip the x plus 2. So the x plus 2 is going to move to the bottom. We have to fill the top with the 1. And then on this other side, I'm going to move the y to the top and then the 1 on the bottom. Okay. And so y divided by 1 is just y. So now that I solved for y, I am done there with that step. So this was one step, switching the x with the y. This was another step, solving for y. And then our fourth step is just to switch out that y for f inverse. So we say that inverse function is equal to 1 over x plus 2. All right, number 5. It says given f of x equals 2x minus 5, graph f inverse of x on the same coordinate plane. Find the equation algebraically. State the domain range of both. And then it gives us both functions. So first I'm going to find it algebraically. So instead of f of x, I'm going to replace that with a y. So y equals 2x minus 5. And then we are going to switch the x and the y. And now if you're still confused on which steps to do first, you use please excuse my dear Aunt Sally. But because we're solving equations, we are working backwards. So we go in this order. So instead, we start off with the subtraction. Okay, do I need to get rid of subtraction? Yes, we need to get rid of this minus 5, so we're going to change it to a plus 5. The minus 5 and the plus 5 cancel each other out, and we get x plus 5 equals 2y. Then there's no addition that we need to get rid of here on this side with the y. We're just looking at this side with the y. Okay, there is no division, but there is multiplication that I need to get rid of. I need to get rid of this 2 being multiplied times a y. So we need to do the opposite and divide. These cancel and we get x plus 5 over 2 equals y. Okay, so now that we solve for y, now we know our f inverse function. That's our last step. F inverse is of x is equal to, and so I know this is getting kind of messy, but it's equal to x plus 5 over 2, which is what goes in this little space. All right. So it says state the domain and range of both functions. So let me go ahead and graph these. So the original is already graphed here. We can graph the inverse by reflecting it across this line. We can graph the inverse by graphing this line, whichever is easier for you. I'm going to go ahead and show you guys how to reflect this across a diagonal line. So because this one is going across, then we need to go across the square. So instead of going straight, we're going to go across the square and we're going to count the spaces. So that is 1, 2.5. So you count half, 1, 2. And so the point for your new line is going to be there. So let's count the next one. This is 1.5. So you count out 1.5 diagonally. All right, this next point is just a half away. So we count out 1/2. Oh, and then the other half is on this point here. And then this one is on the other side of it. So when we reflect, we go to the opposite side of that line. All right, so we're going to go ahead and connect these points. Now you can use your ID to make a nice straight line. Unfortunately, I cannot do this on here, so it isn't the straightest line. All right, so our domain and our range. So because these are lines, they will go on forever and ever in both directions. So for our domain, it is going to be x such that x is an element of the real numbers. Same with the range. X such that x is an element of the real numbers. Okay, if you don't want to write it fancy like that, you can write it in interval notation. So it goes from negative infinity to positive infinity. And it will be the exact same thing for the range, negative infinity to positive infinity. Okay, now these two, the domain and the range should be the same, and these two, the domain and the range should also be the same. So we're good here. All right, the next one says, given f of x equals the square root of x plus 3, graph f inverse of x on the same coordinate plane and find the equation of f inverse of x algebraically. So let's go ahead and work backwards here, looking at the graph. Let's go ahead and graph it. It is 1.5 away. So then the next point is going to be half and then 1 away. So this is 1 equal. All right, this next one is 1.5 again. So half and then 1. And that is going to be our new point. This next one is half away. So then half away is going to be this next new point. Right, this one is 1.5. So half and then, oh, I'm going to move up. Half and then 1 away. And so when we connect these, if you notice, f of x is your square root function, so its opposite has to be your quadratic function. But notice how it's only half of the parabola? So that's why you have to have a restricted domain for this one, because if you include this opposite side that comes out this way of your parabola, then it would not be a function when you graph the inverse, because the inverse would be not a function. So here they want us to find f inverse of x algebraically. So we're going to go ahead and set it up. Y equals the square root of x plus 3. And then what we're going to do is we're going to switch the x with the y. So x equals the square root of y plus 3. Now, I know I did say, please excuse my dear Aunt Sally. And there is addition that we need to get rid of. But the addition is inside of the square root, so we cannot get rid of the addition first. We have to go all the way, and it's kind of like a parentheses. It's inside there with the y, so we need to go ahead and start with that part first. So we need to get rid of this square root by taking the opposite, which is squared. So what you do to one side, you have to do the other side. And we get x squared equals, here the square root and the squared cancel each other out, and we're left with y plus 3. And then we start our steps all the way from the beginning again. So we need to get rid of this addition by subtraction. This cancels and we get x squared minus 3 equals 4. Our last step is to switch out that y with f inverse of x, and I'm going to go ahead and write it in here. X squared minus 3. So that is the opposite. Now the only way that this can work, like I said, it has to have this restricted domain. So it has to go from, I believe we have it from 0 on your x-axis all the way to infinity. And then here, if we notice for our range, our graph here starts at -3 and it goes up to positive infinity. Now, if we check our square root function for the domain and the range here, our domain starts at -3 and it goes all the way to positive infinity. And then our range goes from 0 to infinity. And as you notice, your domain and your range are opposites of each other on your inverse functions. This one corresponds to this one corresponds to this one. All right, last, to verify algebraically that two functions f of x and g of x are inverses of each other, we must show that f composite g of x equals x and g composite f of x equals x. So here our f of x is 4x plus 16 and our g of x is x minus 16 over 4. So the first one is we take our f function and plug in our g function. Okay, so here we have f of, and then we are going to plug in our g function. So here my g function is, let's see, x minus 16 over 4. And this one over. So now I am going to take my f function. So this is my f function right here. It is 4x plus 16. So I am going to write it out. 4, and instead of x, I'm going to leave this part blank, plus 16. And so inside of this blank, I am going to plug in my g function. So I'm going to put x minus 16 over 4. And then I'm going to simplify. So if I go ahead and multiply this, when I multiply 4 times the x minus 16 over 4, the 4's cancel each other out. And I am left with x minus 16. And then at the very end, I still have this plus 16 there. So the minus 16 and the plus 16 end up canceling each other out. And we are left with just x. Okay, so the first part checked off when we did f composite g. We want to be left with only x. That's how we know they're inverses of each other. but we also have to plug it in the other way around. So we are going to take our g function, and they want us to plug in our f function. Now my f function is 4x plus 16. So what they want us to do is start off with the g function. And so my g function is x minus 16. So we're going to put a blank minus 16, and we're going to divide it by 4. And in that blank, we are going to put 4x plus 16. Okay, so then the plus 16 and the minus 16, there's nothing outside of these parentheses that we need to distribute, so we can go ahead and go straight to combining these two. So the plus 16 and the minus 16 cancel, and we're left with the 4x that's on the top, and then on the bottom, we're left with over 4. And so in this case, the 4's cancel each other out, and we're just left with x. So it works out. So for these problems, I'm looking at your work to see if you set it up right, if you set your composites right, and then how everything cancels out. All right, so here we have f of x equals the square root of x plus 2, and g of x equals x squared minus 2 for x is greater than or equal to 0. So the little note that it has here for x is greater than 0 means that that's the only part that makes the graph the inverse. Okay, so that's what we're saying for it to actually be a function. All right, so let's go ahead and try the first example. So we have f of g of x. So we're going to start off with our f function. And then in our f function, they want us to plug in our g function. So in this case, my g function is x squared minus 2. Okay, so I'm going to take my f function. My f function is the square root of, oh, don't put an x. We have to leave a blank there for our g function and then put plus 2. And so inside, I'm going to plug in my g function, which is x squared minus 2. And so there's nothing outside the parentheses for us to distribute. So this minus 2 and this plus 2 can go straight into canceling out. And we are left with the square root of x squared. And so the square root and the squared cancel, and we're just left with x. All right. On the next one, we have g of f of x. So we take our g function. So it's g, and we are going to plug in our f function. In this case, our f function is the square root of x plus 2. And so here we take our g function. It's going to be x squared, so we're going to leave it blank squared minus 2. And in that blank, we are going to plug in the square root of x plus 2. And so here the square root and the squared cancel each other out. And we're just left with x plus 2. And then this minus 2 that's there. And then the plus 2 and the minus 2 cancel each other out. And all we're left with is x. Yes, so it works. All right, so after you're done with the notes, go ahead and get a head start on the assignment. You guys will have time to work on it tomorrow also, but you need to use your time wisely. Remember, anything you do with the substitute, including the notes and the assignment, is going to be a test grade, and you need to turn it into the substitute. I will not take it on Monday, so you need to turn in both the assignment and the notes to the substitute today, and then you guys will get it again tomorrow. If you have any questions, feel free to message me on Google Classroom or through the Remind app. Thanks. Have a good weekend. We'll see you guys on Monday. Bye.